strategy, customer requirements, and the practical challenges faced where technical and commercial priorities overlap. Coming from one of the largest manufacturing companies in the UAE, SYED has been closely involved in delivering solutions that support hygiene, safety, and operational efficiency across critical sectors. In today's session on hygienic equipment and healthcare sector, he brings insights shaped by hands-on field experience, customer interactions, and a deep familiarity with the standards and expectations that define modern healthcare environments. Please welcome Mr. KHALIL. The floor is yours.
Right. Good evening, everyone, ladies and gentlemen. Firstly, I would like to thank the organizers for giving me an opportunity to present the know-how on a hygienic specification or a hygienic design and application unit. Coming from a background of a manufacturing industry where we have been producing, designing, and manufacturing such units for the past 10-15 years, I take immense pleasure in sharing the know-how of the concept or the criteria which goes into the design of such units for these applications. I've made sure to keep my presentation a little basic so that I can cater audiences from fresh engineers to senior engineers who are attending this. My presentation flow will be about where the hygienic air systems are required, what are the problems associated with the biological agents, how an air conditioning system becomes the source of a biological agent, and what are the standards defined in the industry to take care of these biological agent contaminations or things like that. If I have to summarize the hygienic requirement in a sentence, it would be that, it states that your air conditioning equipment should not deteriorate the quality of air when it is served to a particular room. That is what complete about hygienic requirement is. So this system, as every system, should maintain a set temperature, a set comfort condition. But along with that, it should also reduce airborne infections, do odor control, and should not be a source of developing any sort of fungal in the air streams. Where the applications of such unit happens, probably it's quite known to everyone, mostly in hospital, pharmaceutical industries, also in food industries, laboratories, clean rooms, and some electronic facilities to go with. Now, what are the health problems associated with these biological agents? To define what biological agents means, biological agents are microorganisms such as bacteria, fungal toxins, which can cause infections, various kinds of infections, various kinds of toxicity, and are often specified as bioweapons in the industries. So it is quite critical for the system to take care of this sort of contamination creating things and make sure that these are not transferred through the airstream to the critical areas where the air is being served. Another biological agents could be fungi, which cause lung infections from mild to high lung infections, can also have sick building syndromes, which is related to headaches when you visit a certain area. When you come out of it, you feel headaches, allergies, or things like that. They also cause something called a nosocomial problem, which is sort of an infection or disease which you develop while you visit a hospital or a clinic within 48 hours, which you didn't had before visiting that. So these are some of the biological agents which comes in contact with the people visiting such critical areas where hygiene is of requirement. Now, how does an air conditioning system adds to this biological agent is that one is the improper design. Okay, when I say improper design, when we go forward in the presentation, you would see there are certain guidelines been defined by certain standards like VDI, DIN on how a hygienic air handling unit is to be made, what sort of material selections has to be, done to make that unit suitable for such applications. One more critical application or one more critical point where the biological agents are developed are wherever you find water stagnated, which is predominantly in the cooling coil or the drain pans. Another source in the air conditioning unit could be the rubber or the porous gaskets which you use basically. That could be a source of developing fungi or bacteria or these kind of biological agents. Now a system, as per a healthcare definition, what it is required is not only to maintain a comfort cooling or an ambience, but also to make sure that there is no bacterial and fungal growth basically being occurred in the unit or through the unit. To make sure that the unit itself has has been designed that it can be easily accessible, it is easily cleanable. The materials used inside the units are also to the standards which are defined in the VDI and the DIN standards. Now when I go to the standards, there are a couple of standards which comes into the air conditioning forum of hygienic application. One is the VDI 6022, which is stating about the ventilation and the air conditioning equipment. And the other is the DIN 1946 Part 4, which is more sort of a stringent design when it comes to hygienic application. But it majorly focuses on the design of the AHU itself than the question on the ventilation part or the airstream part. Along with that, the same hygienic unit also has to follow certain standards of Eurovent, which is the EN 1886, confirming to certain mechanical characteristics in the unit, and the 13053 standards. So I'll just give you a glimpse of these standards, what this objective of the standard and what are the scope of the standards. So the objective of the VDI 6022 standard is to measure the hygiene and to prevent the disease as well as to maintain the health in the system. The scope of VDI is not only for critical application, but it is defined for any room, probably this room as well. VDI design has a design guidelines to the standards of any room which are being occupied, more than 30 days in a year time, basically. To go with that, the other standard in hygiene applications is the DIN 1946, which is a combination of VDI 6022 and other German standards of ONAM H6020, where the scope is more into the building rooms of critical applications of hospitals, day clinics, sterilization facilities and all. What the standards classifies is that it classifies hospitals into two zones, in two classes. It's class 1 and class 2. So class 1 will be the operating room where there is a high requirement of hygiene and low germ concentration. Further, the class 1 room is divided into 1A and 1B, where 1A, if you could see in the picture, is where the doctor is probably performing the surgery on the patient. That is your 1A class and the class 1A. The class B is in the operation theater, but not directly in contact with the patient where the surgery is being performed. Now, what does the standard say is that it states about the location of components, that each component being used in the air handling unit has to be easily accessible and cleanable, so there is no growth of fungi or no growth of bacteria which can carry to the airstream. It also states about the surfaces and the materials which are being used in manufacturing a particular air handling unit which comes in contact with air. So for the location of components, as defined by the 1946 4 standard, it should be easily accessible in a sense that even the cooling coil, the drain pan, everything which comes in an air handling unit can be easily removed, clean, and accessible to the maintenance person. Second is the air handling unit itself shall always be designed with a supply and a return or a fresh air damper, where when the unit is not in operation, the dampers are fully closed and there is no contamination been happening in the air handling unit itself. The ducts as defined in the DIN 1946 standards should be as short as possible, so there is no more contamination being carried out. There should not be any sharp edges also along in the duct, basically, and it should be abrasion proof, smooth inner surfaces. The material for those particular units, it's always defined as inner skin to be stainless steel 316 or stainless steel 304. Smooth surface for easily cleaning. Though powder coated GI is also acceptable, but not in DIN standard. The VDI standard does allow powder coated inner skin also as an alternative. The gaskets, as I told you before, the rubber or the the phosphorus material used in any handling unit could be a source of development of the biological agent. So those all materials has to be certified with a VDI 6022 standards. So the materials which we use are conventionally different than the gaskets which you use in a conventional air handling unit. And this has to be certified again to the VDI standard. The inner surfaces shall be abrasion proof, smooth to avoid any injuries, no sharp edges to do with. Some filtration requirements, depending on the class 1A or class 1B, it's been defined that for a DIN standard, minimum 2 filtration for class 2A and minimum 3 for class 1A has been defined, where there should be at least a pre-filter, a fine filter, and a HEPA or F9 filter in the end of the air handling unit. Another key point how it differs is those filters which are being used in the hygienic air handling units. They are biostatic coated. This means the fungi or the the bacteria which has been developed in the filters are not multiplied or carried forward in the airstream of the air handling unit. The filter area, there is a sizing been given that it should be greater than 10 meters square per meter square of the area, and the filters to be certified to DIN standards again. So any components which you're using has to be having a certificate of VDI or minimum VDI or DIN for the parts to be used in the hygienic air handling unit. Finally, with the fan section, DIN 1946 standard defines for direct driven fans only. You cannot use any belt driven fan, whereas VDI standard allows using of belt driven fan also with some special coatings and everything. So the fan section has to be again with all the wiring has to be with stainless steel conduit. There has to be an inspection window, a bulk light for maintenance where people can do easily accessible and do the proper maintenance of that particular fan section, and should have minimum flow measuring devices where you can measure the flow or know that the flow is established in a unit, or the dampers has to be shut down in case of no airflow. To go with that, as I told you, the specific hygienic air handling unit should also follow the Euro 1 standards, which is the EN standards for 18186, which is comprising of the mechanical characteristics of thermal break, which is T1, T2, the thermal bridge factor, the F9 filtration factors. All those also are mandate in the hygienic air handling units. And the AHU rating or the EN ratings of the classes, different classes of air handling unit also applies on the same hygienic air handling unit. So that is it about the hygienic.
Thank you, Syed. Any questions? Very clear. Thank you. Our second presenter for today, third session, is Mr. GABRIAL Majdalani. Mr. Majdalani holds a bachelor degree in mechanical engineering from the American University of Beirut and has completed advanced studies at the University of Texas Dallas School of Management, thus combining both technical excellence with business and practical contracting expertise. Mr. Majdalani is currently the managing partner at Majdalani Engineering and Trading. He is a licensed professional engineer in the US and Lebanon. Mr. Majdalani brings over 40 years of specialized experience in both mechanical engineering design and mechanical contracting, working as part of integrated project design, build teams to develop efficient and cost-effective engineering solutions. His portfolio reflects a particular focus on healthcare, education, and institutional facilities. His notable projects include those in Lebanon, like major hospitals projects in Beirut, and the Arlington Lot J residential complex in Dallas, Texas. His international experience is vast, having designed and overseen mechanical systems for 2 more educational centers across multiple countries, including projects in Armenia, Albania, and Uzbekistan. Mr. Majdalani's comprehensive experience bridges the gap between engineering design and practical on-site executions, ensuring seamless project delivery. So please, Mr. Majdalani, floor is yours.
Good evening, Muhammad. Thank you for this royal introduction. Islam. عم بتطلع بس حوالي هيك عم شوف إنه people who are still here are really interested in the subject. Right? Okay. UV disinfection is not a new subject. It's not new. It's decades old, maybe 200 years old. What's new really is how we harness this technology today to better improve our indoor environments. That's what we were going to talk about. Let's first at least remind ourselves what is UV light. UV light is a wavelength of light that falls between the X-ray and the visible light. And it's been divided into 4 sections: UVA, UVB, UVC, and UVV. Why? I don't know, but there are 4 sections. Our interest is UVC, and specifically one wavelength, which is the 254 nanometer in that wavelength. This would be our interest and discussion. Now, it's been proven through laboratories, tests, standards, that this frequency is extremely effective in neutralizing pathogens. And by the way it neutralizes pathogens is by hitting the pathogen, disintegrating the shell of the pathogen, and hence the pathogen will die in its place. Now we talked about the UV light. Let's talk a little bit about what are pathogens made from. As far as I know, there's 3 types of pathogens. We have the bacteria, the viruses, and the spores. Example of bacteria: pneumonia, Legionnaire's disease, many others. Viruses, we all know COVID, influenza type A, influenza type B, and many others. spores, they are mildew, afuni, algae, anything that grows in an air handling unit, a drain pan. Now, all these pathogens, what do they have in common? All these pathogens are made of DNA, which is a nucleic acid, and they are all covered by a shell made out of protein. It's a protein shell with a DNA inside. And they are very active, and they multiply very fast. So what does the UV light do? Actually, the UV light hits the protein shell, and it disintegrates the shell. And it immediately becomes either powder or non-existent. Hence, the DNA cannot be active anymore and cannot multiply and replicate. In a graphic manner, on the left-hand side, this is a normal DNA, normal pathogen being multiplied and divided. You hit it with a UV light at a wavelength 254, and it creates such like a roadblock. It stops these pathogens from multiplying and moving around. Hence, they disintegrate in their place. Don't take my word for it. There are international standards and guidelines that talk about this and proves it through many lab research and design. ASHRAE has 3 standards. They have 185.1, which talks about the airstream disinfection. ASHRAE 185.2 talks about surface disinfection using UV light both. Standard 241 acknowledges the use of the UV light to sterilize airstreams. You have the Center for Disease Control also, standard, and the ISO standards. In the air conditioning industry, we are interested in 3 types of disinfection. One is the coil and surface irradiation. Second is the induct stream disinfection. And the third one is the upper room air disinfection. These are the common way UV light is used in the air conditioning industry. And we will talk about each one alone briefly. Let's start with the UV coil disinfection. The UV coil disinfection is rather simple. You place a light downstream of the coil, let it hit the coil continuously even when the unit is off, and it should actually disinfect this coil. Now the question is why downstream, not upstream of the coil? As we all know, the condensation and the water in the cooling coil happens at the last 1 or 2 rows of the cooling coil. When the coldest air hits the coldest water, that's when the air loses its moisture and we have the ability to have algae growth and bacteria growth. So the location of the air UV coil disinfection light is downstream of the coil. Here is an example that we actually performed and tested on an actual situation. We have a situation where we have a coil, a huge coil actually, almost 4 meters wide, 2.5 meters high. We input that into the software program to select the UV light for the coil disinfection. We also input the average dose that we need in microwatt per centimeter square. These values are indicated in ASHRAE standard 185.2. It's not something arbitrary that we came, but after tests and laboratory tests, it's proven that the average dose needs to be with this power. Obviously, also, we have indicated that we're going to put the light downstream of the coil. Now, the output that the software will give us a map showing on the x-axis the width of the coil. The left y-axis is the coil height. The right side y-axis shows the intensity of the light that is required. And if we take a look at the 700 microwatt per centimeter square, it falls between a little bit above the 600, and it has the light orange color. And so, according to the selection, you need to make sure the entire coil is covered with light orange and lighter. So the program gave us an output that says you need, for this large coil, you need 4 lights. Each one is 154, I think, centimeter long. With each watt is 164.3 watts for each lamp to do the proper disinfection according to ASHRAE 185.2. Now here, this is a cross-section. On the right hand, actually, this is the actual lamp that was installed 4 of them. On the left-hand side is a cross-section through the coil. We see the coil. I need to go back and explain one thing that I forgot. What's important also is the distance between the bulb and the coil. You see here we use 40 centimeters. If you shorten this distance, your coverage, your light coverage of the coil becomes less, and you need more lights, but less power. If you make it longer, then you have a wider coverage, but you need more power to cover the coil. In our case, because of practical purposes, we have the motor and we have the coil, and we found a happy medium between them at 40 centimeters to install these lights. One thing here also, during the cross-section of the installation, you see something called the reflector. We need to have a reflector behind the light, either stainless steel or something that's really shiny, to reflect the entire light beam towards the coil and not anywhere else. So this is an integral part of the installation, is to have this reflector. A real picture of the installation. This was a retrofit installation after COVID to make sure that this office building is ready to be reopened again. We have the 2 light bulbs at the top and 2 at the bottom, 40 centimeters away from the coil, and this was the complete installation. Now moving along to another part of the air disinfection, which is the airstream disinfection. Now, the airstream disinfection has a bit more variables than the coil disinfection. The first and most important thing we need to understand that the UV light bulb that is involved in the air disinfection needs to run parallel to the airflow, not perpendicular. It needs to be along the airflow. Why? Because you need the air to be exposed to the lamp throughout the lamp's length. If you select an air handling unit and they tell you, give you a UV section with 4 or 5 lights perpendicular to the airflow, you're paying for nothing. It doesn't work. So the first option, the bulb needs to go parallel to the airflow. The second most important is the velocity, the speed of this air over the bulb. The lower the speed, the more effective the system is, and the less wattage you need. The best speed actually is 2.5 meters per second or 500 feet per minute across a plenum. So you need to make sure you have a plenum that can give you the entire airflow at 2.5 meters per second before you decide to place the lights. If you place these lights in a regular duct where you have 1,500 feet per minute, it's a waste of money. It doesn't do anything. So To get disinfected, you need time. You need resistance time. Resistance time is, it needs to take its time, slowly moving over these lights. The other important thing also is the type of plenum. You can use a galvanized steel plenum. It has a reflectance, which is okay. You can use, the best one to use is stainless steel plenum because it reflects the light very well. What you do not want to use is a plenum that's internally lined with a black lining, because that's also a waste of money. No reflectance whatsoever of the light. So these are the important things: the direction of the light, the air velocity, reflectivity of the light, and the intensity, of course, of the UV light. One thing that was also found out that the lower the temperature of the air, the less effective the UV light is. It gets degraded with lower temperature. So considering all these factors, we went back to the same air handling unit. We decided to place these lamps in the mixing air plenum, where you have the return air coming and mixed with the fresh air. Why? Because we have the lowest velocity. We have 500 feet per minute across that plenum, and it's a huge plenum, and this is where we decided to put these lights. Also, the air temperature is not that low as downstream from the coil. So here we input the width of the duct, which is also almost, the plenum is 4 meters, 2.5 meters high. The amount of air we need to move, we need to input, which is almost 55,000 CFM, or 95,000 meter cube per hour. We had 4 air handling units like this. The lowest air velocity we could achieve is 2.75 meter per second because of the size of the plenum. Also, the dosage that is required for air stream disinfection, it is found in the ASHRAE 185.1. This ASHRAE standard is different than the ASHRAE standard for the cold disinfection. The cold disinfection, actually, it talks about surface disinfection. It's 185.2. 185.1 talks about the airstream disinfection. So, and this dosage is actually indicated in these codes. So we plug in all these numbers. We get an output that we need 2 batteries of lights. Each one is 76.2 centimeter long. And they look, on the left hand, they look like this. The diagram shows the location of the lamps, the X and Y location, and it shows this dark mauve color. It means the whole plenum is actually covered by these lights. Now, one thing I have to, we'll get to it on the other slide. Here also you can see on the right-hand side some information that's really surprising. To 100% disinfect this amount of air from COVID virus, I think you need to have 4 passes of the air over these lights to get 100% disinfection. So if the building is unoccupied, they leave work, and you want to disinfect the building, you need to run the system that you have to make sure you have air, 4 times the air changes over these bulbs. Comparing it with influenza type A, even if you go with 8 times, you're not going to be disinfect the whole building from influenza type A. It's much more aggressive and much more transferable than COVID. TB also is the same way. You need to pass the air 7 times over these lights to get disinfected. So here is the actual installation. This is the mixing air plenum. We installed these 2 lights. They are actually a light battery. They're not only one light. They're a combination of 5 lights on each side. And these lights are controlled by this controller. And outside the air handling unit, you would see this, each battery of lights has a screen that shows these lights. It shows whether they are on or off. It shows the lifetime of the light, how many hours they've been on, and whether any light is damaged or not. Now, I showed a slide on the right-hand side, which it's a word of caution. When you deal with UV lights, two things you have to avoid: looking at them or making them shine on your skin. You'll end up blind or with cancer. So make sure when you deal with UV lights, remember these two things. All these systems, they have safety connections. If the air handling unit door is open, they turn off. Other systems that are widely used also for air disinfection using UV light is the upper room air disinfection. By the way, all these are indicated in the ASHRAE manuals and the systems and the applications. The passive systems, as you see on the left-hand side, they look like fan coil units, except they have a UV light inside them, and they rely on conduction, and they move air around them very slowly, and they're very effective. They're good in hallways, hospitals, airports, anywhere where you have massive number of people moving around. We also have them as active, where you can install a fan in them, and they'll move air much faster. Now, this is the last of the Mohicans. The biggest technology now that's been used in the US is the robots UV light stands. On the left-hand side is the operating room disinfection robots. They are extremely powerful lights. You push them into the OR, you close the door, wait 5-6 minutes, and the OR is completely disinfected, chemical-free. No chemicals are used. Some ORs, they use 2 of them. They move around using a program, and they disinfect most of operating rooms like this. They're much cheaper, much faster, and the light gets into areas where chemical cleaning does not get, to small corners. Anywhere the light shines, it will disinfect. On the right-hand side, also it's used for odor control in kitchen hoods and for disintegrating also fat protein cells. With that, that's my brief presentation. I hope you enjoyed it and you're still awake. Thank you.
Thank you, Gabi. Any questions? Come in, clear?
I have one question.
Yes, thank you.
Afternoon. Yes. Afternoon, I want to ask you.
Oh, okay.
Inline disinfection.
Sorry?
Inline disinfection. We cannot achieve certain velocity. Can we put like 2 or 3 in inline to get more efficiency?
Yes, of course. It will work. It will work, but it will cost you. The cost is not cheap, and the power you use is not cheap. So you need a lot of power. The faster the air, the more power you need in the light, because you're passing the air over.
If you don't have any choice.
Yeah, if you don't have any choice, you can.
do it.
You can, of course.
I have one question on the location of the UV lamp in the HACHEM. You said it should always be on the downstream, right?
On the coil.
On the coil, on the down, right? But there is one recommendation which the supplier also gives. That is, you use the UV lamp for cleaning of the coil. That there is nothing. But if there is a moisture eliminator, in front of the cooling coil, then the UV lamp does not penetrate the eliminator and cleans the coil. So it is recommended to do it on the upstream if there is a moisture eliminator in your coil.
And the reheat coil also, you have to, you have the reheat coil, you
Yeah. 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 So just to add on as a design recommendation, it's not only on the downstream, but when you have a component in front of a coil, then you can even put it on the upstream of the coil.
It's more effective.
Of course, that is true.
There are some cases you can.
True.
It's better anywhere than nothing.
Yeah, of course. I agree with that. Thank you.
Thank you. Our third and last presenter for today is Mr. EDDY HACHEM. Mr. HACHEM is a mechanical engineer with 8+ years of experience in the pharmaceutical field. His practice is mainly in facility management and maintenance, in addition to high-impact project execution in regulated environments. Currently, his focus is on his company, ITS, specialized in steam and industrial solutions. In addition, advanced thermal and process engineering solutions. Please, Mr. HACHEM, the floor is yours.
Hello, thank you all for listening. آخر session. I'm going to make it as brief as possible, but this is a very, very important session. اللي هي بتحكي عن ال sanitary production, عن ال clean steam, عن ال pure steam. نحن بلبنان بلشوا الفارما اندستريز يعملوا شيفت هلا بيوروب عم يعملوها بالاف ام بي. سو اذا عندكم questions فيكم تلاقونا نحن بالبوث نمبر 29 بتشوفوا النيو نانو بابل تكنولوجي كمان خاصه بالدي سكيلينج. اتس ذا نيوست تكنولوجي. anyways ما حطول عليكم كثير بقى. types of steam, industrial, some people call it plant steam كمان. filtered steam, clean steam, pure steam. Clean steam and pure steam, they almost have the same properties. بتحبوا we can take it outside أكيد. Filtered steam is usually called culinary steam. هي simply by using a filter. بأتكا عندهم stainless steel filter بيكون 1 to 5 micrometer. أكيد بحطوا PRV قبله because it works on 0 to 5 bars. وبدكم pressure gauge بعده لتأكدوا إذا الفلتر is still working or not. Okay. ننقل للclean steam. The clean steam, what you need for clean steam is two things. بدكم industrial steam, بدكم purified water. Purified water is different than WFI water for injection used in pharma. Purified water هي simply قاطع ب softener, sand filter, reverse osmosis, UV, deionizers صار عندكم purified water. وبتقطع بالclean steam generator بصير عندكم clean steam. Clean steam can be in direct contact with food. So the F&B industries فيهم يستعملوه. It cannot be used in pharmaceutical injections. يعني إذا عندكم شيء intravenous لأنه منه معمول من water for injection بضل فيه المايكرو بكتيريا ريت شوي عالي. الميكروبايل ريت شوي عالي. So to have pure steam أكيد بدكم sterile water or water for injection. يعني بعد ال RO والdeionizers بيكون عندكم distillery. Distillery بتعطيكم water for injection. السبيكس تبعها water for injection هي بده تكون conductivity less than 1.1. بدها يكون الاندوتوكسين ريت less than 0.25 EU per milliliter. أكيد الميكروبايل ريت less than 10 CFU. بينما عند الكلين ستيم فيكم يكون less than 100 CFU. هيدا الريتنج تبعها. والتوك نمبر لازم يكون less than 500. أكيد الدراينس تبع الستيم بدها تكون 95% and above. والسوبر هيت بده يكون less than 25 degrees. ليه بنستعمل سانيتري ديزاين؟ رح احكي عن شيء جماعه الاندستريز كلهم قاطعين فيه، اللي بيشتغلوا بالفارما اندستريز واللي بيشتغلوا بالاف ام بي. صار في ديماند بالسوق كثير منيح على برودكت معين. بلشنا كونسكتيف برودكشن. عملنا اول نهار برودكشن، ثاني نهار برودكشن، اجوا جماعه الكيو سي فحصوا الفاينل برودكت، طلع عندكم مايكرو بايل ريت كثير عالي، طلع سي اف يو كثير عالي، عندكم بكتيريا بالبرودكت، البرودكت للكب. ما في مشكله، في بروسس اسمه سي اي بي بيعملوه لللاينات كليننج ان بليس. بعده بيعملوا SIP sterilization in place، نظفوا اللاينات، نرجع نبلش ثالث نهار برودكشن. هيك على اساس بتمشي الموضوع. ثالث نهار عملوا برودكشن، كمان طلع الميكروبايل ريت كتير عالي. هون انقسم المعمل. هيدي كل معمل بلبنان بيقطع فيها على القليله مره اذا ما عنده سانيتاري لاينز. بينقسم المعمل لثلاث بارتس. جماعه البرودكشن اللي هن حاطين البروجرام بدهم يشوفوا الحق عمين، ما بدهم يشوفوا شو المشكله. حق عمين بينشغلوا كل نهار ينبشوا الحق عمين. في عندكم الانجينيرنج والمينتنس ديبارتمنت اللي هو دائما الحق عليه، لان الانجينير هدول الباد بويز اللي بيعرفوا كل شيء عاده. في عندكم جماعه الكواليتي كنترول، هن اللي اكتشفوا المشكله، هن اكثر ناس مبسوطين لانه هذا الشيء الوحيد البوزيتيف اللي لقيوه بنهارهم، هي تست البكتيريا. ما انحلت المشكله، بفوتوا بمرحله بدهم يفكوا كل اللاينات، يعملوا تشيك اب على كل فالف بفالفو، ايام كمخ، ايام مقدوح السيل تبعه، اي في مشكله باللاين منقور شي مطرح. وهيدي المشاكل اللي بيعانوها عاده بالفارما اندستريز وبالاف ام بي. This is why من الاول عملوا sanitary design، حطوا sanitary equipment، you won't face these problems. شو يعني sanitary design؟ sanitary design و sanitary equipment يعني اللاينز تبعكم بده يكونوا على ستاندردز معين. You need to follow a certain surface finishing، رح نحكي عنها بالnext slide. You need to follow a certain access على الاكويبمنت تبعكم، كمان رح نحكي عنها بالnext slides. We need to follow أكيد certain aspects. The seals used they need to be USP approved, FDA approved، وهيك بنمشي بالsanitary design. alright. نحن بأتكا مثلا هيدا البول فالف is a sanitary ball valve. إذا بتلاحظوا it is a full bore ball valve. هيدا it is machined الwetted area مطرح ما بدق البرودكت it is machined from a single block. بيجيبوا one block of stainless steel 316L و they machine it until they get the wetted area all together. ما في بيكون welding بقلبه، ما في grooves، ما في chamfers، ما في شيء نافخ. هيك بيكون السانيتاري ديزاين. في ليزر هذا. اوكي سو اذا بتلاحظوا هون السيلز ما فيهم اير جابس. سيلز they are without air gaps وعادة بيستعملوا يا PTFE يا EPDM. It depends on the application. في many types of seals we're going to go through them بالnext slides أكيد. هيدا البول فالف it is self flushing يعني بس يفتحوا الاوبريتور ويسكروا على التوربulence تبع الفلو it flushes everything with it. This is why ما بيكون عندكم stagnant points. ليه نحن ما بدنا air gaps؟ لأن الاير gaps هي stagnant point. It is a good area to grow bacteria. وبذات الوقت كل شيء فيه مطارح بتعلي البرودكت من يوم ليوم أو stagnant product point. كمان it is a lovely place for bacteria to grow. So الفالفز تبعكم لازم يكونوا self flushing أو self draining. بس تخلصوا production your valve is totally empty through the line through the drains أكيد. وآخر نقطة بدنا نحكي عنها، حكينا عن no cavities gap free approved seals. في ball valves it is usually used for purified air for pure steam يعني in the utilities section مش in the production line sections. The production line sections في they usually use diaphragm valve مش الباترفلاي الكل بيستعملوا. الباترفلاي قد ما يكون ديزاين منيح بضل في air gaps بمطارح معينة، بضل في stagnant points بمطارح معينة. That's why they use diaphragm valves. Diaphragm valves are flat بالwetted area ما في exposed threads أكيد. It is angle type يعني بس يخلصوا production كل شيء product بقبل valve بينزل باللاين. alright. أكيد السيلز تبعه لازم يكونوا FDA approved. الفالف عند أتكا عنده كمان leak detector. هيدا leak detection line it's a very good feature أتكا عندهم إياها، إنه إذا صار في leakage بقلب الفالف لما والاوبريتور مش دائما operators are not always around utilities. قد ما يقولوا لك بحط واحد يبرم بالنهار they're not always around. So بفالف مثل هيدا you can put pressure switch مثلا إذا صار في leakage بقلب اللاين which is harmful for the product. it is detected by the pressure switch على البي BMS عندكم. So this is it. بدي احكيكم شوي عن surface finishing. Surface finishing في mostly known two types, electro polishing والmechanical. Mechanical فيكم تنزلوا فيه ل 0.8 مايكرومتر تقريبا. الالكترو بوليشنج فيكم تنزلوا 0.5 مايكرومتر and less. هلا في انفورميشن ما كثير ناس بتعرفها انه نحن ما لازم ننزل تحت 0.3 مايكرومتر، مش كل ما نزلنا بالسيرفيس فينيشينج اتس جود. اذا نزلنا تحت 0.3 مايكرومتر السيرفيس صارت كثير سموث، بكتيريا بتعلق عليها مثل الفانتوز على الشباك. So good surface finishing بالwetted area لازم يكون between 0.3 and 0.5. For FMB industries it is acceptable يكون between 0.5 and 0.8. يعني mechanical surface finishing is good also. خلينا ننقل شوي بس هيدول two types of PRVs. If you look at the industrial part بكعبوا في spring، هيدي السبرينج بتدق بالستيم. It is exposed, it is a threat to the line. اوكي اذا بتلاحظوا الانترنس تبعه فيها exposed threads، هدول الثريدز بحشوا بكتيريا، بحشوا product from one day to another. في air gaps. بينما اذا بتطلعوا على السانيتاري تايب ما في exposed threads. it is self drainable من تحت، بس يخلصوا production كل product او بس steam يعمل condensation بينزل من كعبه للبي ار في، بيفضل بي ار في توتالي، واكيد فول بور من جوا و اف دي اي ابروفد سيلز تبعه. هيدي السانيتاري ستيم تراب، ثيرموستاتيك ستيم تراب، فيها بالو وفيها بول بكعب البالو. اذا بتلاحظوا ما فيها exposed threads. رح فسر شوي صغيرة عنها. هيدا البالو في ليكويد بقلبه من جوا، بس يصير فيها مي الستيم تراب بيسقع البالو. when it gets cold it shrinks. when it shrinks بتعلى البول بيفضل ميات من تحت. بس يخلصوا الميات صار عندنا ستيم، بس بيسخن البالو it expands البول بتسكر الستيم تراب. this is how it works. واكيد easy access ينظفوها، يعني هي it's simply one clamp تنفك، بيتنظف السيل، بيتنظف قلبها. you can check for روج إذا صار فيها روج. إذا بدكم تسألوني عن الروج فينا نحكي بعدين عنه. لأنه البيور ستيم والبيور ووتر it's nice, it's clean water, it's the cleanest يمكن، بس it is very 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 aggressive. it is an aggressive material. هيدا مش الكل بيعرفها كمان، إنه البيور ستيم it is very aggressive on metal. ما فيها ions تاكل الميتال. That's why we use stainless steel 316L for it، لأنه عندها passivation layer تحميها من الاتاك تبع البيور ستيم. The 304 stainless steel 304 is not good for pure steam. هلا فيكم تستعملوه على فترة قصيرة بس دغري بيسود من جوا وبيتاكل، بيصير شوي شوي بيضعف الميتال تبعه. اخر شيء اخر تو سلايدز عندي اياهم بدي احكي عن ال types of seals. It depends on the application بينحطوا seals at least عند أتقى. يعني عندنا الفيرجن PTFE هي تeflon معروف في السوق. It is the mostly used. تحمل كتير حرارة. It is rigid. TFM it is a higher level of PTFE. هي PTFE مع PPVE. It's better on shear stresses, on creep. It is more creep resistant. Kylan كل الفارما industries عم تستعمله. هي the highest level of PTFE. كمان في EPDM it is used mostly in FMB industries. It is affordable. It is good in steam versus steam and water, against steam and water. بس نروح على الفايتن او ال FPM. فايتن هي اسمها بالسوق يعني بسموها فايتن. FPM مثلا ضعيفة ضد الستيم والمي، بس it is very resistant to chemicals and it is very resistant to fuel. It has good heat resistance كمان. وآخر شيء بدي أحكي عنه هو الستينلس ستيل. نحن في عندكم الستاندرد ال 1.4404 CF3M 1.4409. هيدول usually they are used in food industries. اوكي بس نصير بالفارما بنصير عم نحكي بال 1.4435 بتكون عنده bigger passivation layer. It is more resistant to corrosion. بس نصير عم نحكي بال 316 TI it can withstand higher temperatures. يعني بس نحكي pressure vessels بس نحكي heat exchangers بيروحوا على 1.4571. والاخر ال C22 هي التوب نوتش تبع الستينلس ستيل. It is mostly used بالaggressive places يعني على البحر مطرح ما في very acidic places بيروحوا على C22. Thank you all for listening. انتوا اخر عالم الليله بقيوا you're the last people standing. Please إذا عندكم أسئلة شرفونا تبقوا فيكم you can ask now. Thank you.
Thank you, Eddie. يعني in this way we are closing day 2. بحكي عن يوسف هلا، وينه يوسف؟ اهلا وسهلا جميعا اكيد، وان شاء الله نتامل بكره day 3 كمان يكون interesting مثل هاليومين اللي قطعوا. Thank you all.
Thank you.